have two pretty different sample holders in my hand right now. This one, I'm sure you recognize, is just a 1 centimeter square cuvette. And this is something which is called an integrating cavity. And this happens to be a slightly unusual one in having a very particularly large aperture for samples to go in. More commonly, one would have a much more narrow neck here to put the sample in with a pipette. Why would one choose to use an integrating cavity or a cuvette? Just think a second about what samples you can put in here, okay? What's their defining characteristic? Number one, and absolute, it must be clear. Because if it's not clear, then the light's not going to travel through the cuvette to the awaiting detector, and you'll get an incorrect to a grossly wrong answer. Compare that with an integrating cavity. What can you put in here? An environment that's completely sealed from all external light. Only the light that you intentionally put in enters it, and only the light that you intentionally allow to escape can exit it. And the answer is anything that you like that's light absorbing. So this can be purified protein. It can be protein in a membrane, in a cell. It can be nanoparticle suspensions. This particular chamber is so grossly large because it was designed for intact fruit. You wanted to measure the color of the skin of fruit. Obviously, you start thinking about fruit and other applications, living cells, fermentation. An ideal environment is an integrating cavity for study, because here you have your cells in this completely sealed, potentially thermostated environment with highly regulated oxygen levels and pH levels, so that you could measure anything from as simple as the color of a product, beer, for instance, to the health and vitality of your bacterial or yeast cells as they're growing. Cuvette, perfectly useful for all samples which are clear, but if you want to work with samples which are not clear, that are turbid, cloudy, frozen, particulate, solid, then let's discuss an integrating cavity.